What's going on, guys? Moving on to the next question on the test. We have to show that a triangle with sides n squared plus 1, n squared minus 1, and 2n contain a right angle. So we have to show that it's a right angle triangle. Now, out of all three of these sides, so we have n squared plus 1, we got n squared minus 1, and we got 2n. Out of all three of these sides, which one would you say is the hypotenuse, the longest side? Well, definitely n squared plus 1 is larger than n squared minus 1. And for most cases of n squared plus 1 is going to be greater than 2n. So for example, if n is 5, n squared plus 1 would be 5 squared plus 1, which is 26, and 2n would be 2 times 5, which is 10. Right? There's certain decimal values, I think, where 2n would be greater than n squared plus 1, but for the most part, n squared plus 1 is going to be greater than 2n. So we can pretty confidently label the hypotenuse as n squared plus 1. And then the rest of the sides, n squared minus 1, and then this is 2n. It doesn't really matter which one of these you label n squared minus 1, 2n. So how do we prove that this is a right angle triangle? Well, if it's a right angle triangle, if you remember, a squared plus b squared has to equal c squared. Pythagoras' theorem has to hold. So actually rewriting this up here, if we can show that these two sides, the sum of the squares of these two sides is equal to this side squared, then we show that Pythagoras' theorem holds, and then we show that it's a right angle triangle. The triangle contains a right angle. So what we can do, a squared plus b squared, we could say 2n squared plus n squared minus 1 squared has to equal n squared plus 1 squared, like that. So we could try to prove it. So let's expand both sides. Let's expand the left side, expand the right side. If both sides equal, then we prove that Pythagoras' theorem holds. So 2n squared, you would take the 2, square it, n squared, that would be 4n squared. And then this here would be n to the power of 4 minus n squared plus 1. Right? N squared minus 1 squared. If you rewrite it like that, and then you FOIL out the brackets, you would end up with this here. And then n squared plus 1 squared is like n squared plus 1 times n squared plus 1. So foiling that out, we'd get n to the 4 plus n squared plus 1, like that. And now we could just collect like terms. So notice the n to the 4, that's by itself. Then we have 4n squared minus n squared minus n squared. Those are all like terms, so that would end up being positive 2n squared. Then we have the plus 1 here. And then notice here, we have n to the 4. These are like terms, that ends up being 2n squared, and then this is plus 1. So notice left side equals right side, so we proved that Pythagoras' theorem holds, and we proved that it's a right angle triangle.